Okay, we're back from lunch. It's 2 minutes late, but we're on time. So I'm going to go over Lecture 7, but before I do that, I want to make note that those examples about collections that I was going over before lunch weren't actually on the website. Somebody had pointed it out to me that they couldn't find it, so I went to go look for them, and I couldn't find them either. So I put them out there during my lunch break. So they are in course materials, and it's actually on the bottom of the list of the examples. So all that good stuff is right here, Lecture 6 collection examples. If you click on that, there'll be a zip file called collections, and inside of there will be 4 or 5 examples that I went over before lunch. So if you're looking for those files, that's where it is. If you're looking for the recorded lectures, they're out here too. So, but lo and behold, we are winding down subjects, exceptions, and I/O, 24 slides. So we'll go through this and further our knowledge of Java. Where is everybody? Alright, so in other languages we also have exception handling, so this is not a new concept. However, it is something that is interesting because it's more automated in Java, just like some of the other things we looked at in terms of those collection classes. The overview of the exception hierarchy. We have a couple different layers. So here's a simplified diagram of the exception handling and the hierarchy that exists in Java. At the top we have throwable. And from throwable we have 2 types of things that can be thrown. You're wondering, what do you mean by throwing? Actually, a method can throw something. And when it throws something, it's just the terminology being used to say that it has found something in the runtime environment. One of the advantages we have over using Java versus C++ is that in Java, we're running it in the JVM, Java Virtual Machine environment. We have our own built-in exception handling, as well as garbage collection, as well as file management, security, all sorts of different sub areas. Just like a full-fledged operating system, the JVM is an operating system that runs on top of an operating system. So all exceptions that could possibly happen in terms of a file not found, a method that does something that shouldn't be doing, protection, might be writing over something that doesn't belong to, might be creating or opening a file in an internet environment. They fall into 2 categories. It's either going to be an error or it's going to be an exception. An error is a simple programming problem, logical problem. It's not a syntax problem because the compilation worked. But it's going to be, using the wrong memory or using an object that's been deleted or something. In the exception category, we have I/O exceptions and runtime exceptions. Because we have the runtime environment running, we have the ability to, this is Lecture 7. Is that what you were asking? Or?
I was asking for the security key.
Oh, did they give it to you?
No. It's usually written on the
blackboard. Oh, here's an easy way to remember it. The address of the building, which is 355. ITU. And the last 2 digits of the year, 11.
Oh.
I think it's 35. Is the address here 355?
Yes.
No. The address, ITU, and the last 2 digits of the year. Now you'll never forget it. And neither will everybody at home watching this on video. But you have to be on campus. For those people who are at home, you're not on campus, and I'm speaking to you right now. Speaking to imaginary people who are listening to this, hopefully. But if you're listening to it, more power to you. There you go. If you're in the building, that was the code. But obviously you can't get that at home. Alright, so all exceptions extend the throwable, which immediately splits out into two categories or 2 branches, error and exception. Here's the formal definition for what these 2 categories are meaning. The error is an internal error. The resources are exhausted. It's inside of the Java runtime environment. Very little you can do about that. If you run low on resources, it's an issue. If you've done something that doesn't make logical sense, it's an issue that you basically have to fix in the coding. Exceptions split into 2 branches, I/O exceptions and runtime exceptions. A lot that you can do with that. So we're going to focus on the exception branch, this branch over here, because we can do something with it. Errors are errors, so it's just a matter of going back and redesigning the code. So the 2 branches of exceptions, so you can call this exception handling if you want. We have the extensions that are derived from the runtime exception. These are things in the garbage collection, in the memory management unit, in the security, the protection features of the JVM. We also have something that does runtime checks and things to make sure resources are properly being used. An example of some of these exceptions might be a bad cast, an array out of bound access, which we'll probably usually get like an array out of bound exception that would be thrown from that. Happens because errors exist in the program. It's your fault. The other part, those not in the type of runtime exceptions are trying to open a malformed URL, a file that doesn't exist, a program is good, other bad things happen. Not really your fault. Someone deleted a file, the URL's down. You wrote a Java program that went out to a URL and wanted to get a file from some location and the location was inaccessible. It would throw an exception. Checked exceptions versus unchecked exceptions. Just like in every language, you can leave out exception handling completely. Not check anything and then hope your program never runs into a problem. Kind of unrealistic. In more realistic thinking in the real world, you want to catch exceptions. An unchecked exception is exceptions that are derived from the class error on the class runtime exception. Checked exceptions, all other exceptions that are not unchecked exceptions. So, if it's checked, it's an error. If it's unchecked, you check it, essentially. And if you don't check it, nobody checks it. So, if they occur, they must be dealt with in some way. So, the compiler will check whether or not you have provided an exception handler. If you have, then it will run the exception handler if the exception occurs. So, how do we do this? Here's where that throws comes into place. And I'm going to skip down to this example to show you the throws. You're opening up a file. You have a file input stream, and it's going to throw a file not found exception. That's a pretty common exception. Because if the file is not found, you can't really open it up, and you can't read from it. So you include the keyword throws in the statement of the method declaration to say that we're going to throw this. And when we throw it, we can catch it. So there's like two separate kind of logics with that. So a Java method or the constructor can also do this. Should be declared to throw exceptions under two different situations. So this is the standard kind of behavior. In the first situation, it calls another method that throws a checked exception. Okay, or the second one, it throws a checked exception with the throw statement inside of its body. You can actually put the throw inside of the body as well. Those are exceptions to the two situations where you can use throw. I'll go through some examples in a few minutes. So you declare the method or the constructor to throw an exception or exceptions. You can throw more than one by using the throws clause. Here's our single exception. Here's our multiple exceptions. So this one throws end of file exception and IO exception. So it throws both. You just separate them by commas. So basically you list the you list the names of the exceptions that could possibly be thrown by the activities that you're performing. It makes no sense to put a file not found exception in here or IO exception if you're not doing any IO, if you're not doing any file not found. In fact, if you're not doing anything, you don't have to throw any exceptions really. It's not something you should put in every method. You should not declare an unchecked exception after throws, obviously. There are either outside of your control or they could be avoided completely by correcting your code. So using throw to throw an exception. So the first method we put it on the, actually it's on both in here so we can see it. We can put it on the method declaration line or we could put it in the code and say throw a new IO end of file exception. So throw an exception under some bad situations or maybe just some situations where you really need to check something. And here's an example. A method named readData. Here's our method readData. It's reading a file whose header says it contains 700 characters, but it encounters the end of file after 200 characters. Now you decide to throw an exception when this bad situation happens by using the throw statement. So we can throw, and here's the statement that we're using. Or we could say this longer method, instead of saying throw new IO exception, and what we're doing is we're actually creating a new object of an end of file exception, which we have objects for everything. And so here's another example of creating a new object. And we're not giving it a name. We're not actually giving it, because we're not going to use the object. We're just going to say, create this object. If we have an exception, if this actually occurs, create this object. It's end of file. Here's another way of doing it. End of object E is equal to new end of file, excuse me, end of object, end of file exception E is equal to new end of file exception. Throw E. 2 lines, 1 line. We don't have E up here. We don't have a name. We don't have a reference. And actually, this is kind of an interesting point too, because of what we were talking about earlier today in terms of that reference variable. No reference variable. E would be the reference variable over here, which we're not going to do anything with it. We just want to throw it. Then why have E? But usually we want to go like E dot, what is the message? We want to use the methods on the exception to figure out, well, what exactly happened, so that we can give more information to the user to say, you know, when this exception is thrown, we can deal with it a little bit more intelligently. The entire method will be, we're going to throw the end of file exception, and down here we're going to throw the new end of file. And this is in the middle of the while loop. It says while in has next, and we've seen this already actually in terms of iteration. If the length is smaller than the length of the file, that means we run out of stuff. So we're short. We're only 200 instead of 700 characters. So let's throw this exception and then return S. So using throws to throw an exception, and we'll continue. In the method body, you can only throw exceptions which are the same type or the subtype of the exceptions declared after the throws in the method header. Meaning end of file and end of file, this type or any subtype of this type can be thrown inside. So we have to basically tell the method that we're gonna throw this category, and then we can catch the subcategories or the subtypes. Think of inheritance. You get kind of the concept of that. It has to be the same object line. If you can find an appropriate exception class in the library, make an object of that class and then throw it. Otherwise, you design your own exception class, and you can come up with your own exception class, no problem. Here's one example here. And you might imagine we're extending or inheriting from exception. So you can create your own exceptions and then throw your own exceptions, which is kind of interesting. Exceptions are objects, as I mentioned before. New exception types should be extending exception or one of its subclasses. So we can build, and this is kind of interesting concept because a lot of people think, you know, oh, we can't inherit classes from built-in library classes. And you're sure, why not? There's no limitation there. In fact, people build on the Java libraries all the time. There's a ton of I/O stuff going on with that, especially for special hardware devices and stuff. Input-output is kind of interesting when you're doing it on like a mobile phone versus a computer. And you have to redirect the output, or you're doing some interesting things with it. Different libraries, there's tons of extensions on that. Why creating new extension types? We'll describe the extension condition in more detail, and then just a string that the exception provides. So you might want to be able to extend the behavior, add a little bit more detail, add a little bit more information. Here's an example. Suppose there's a method to update the current value of a named attribute of an object, but the object may not contain such an attribute currently. So how can you update it if it doesn't contain it? And you want an exception to be thrown to indicate that the event is actually occurring in that particular situation. So here we have class no such attribute exception, that is extending exception. So we basically call super to the exception class, and we're going to throw this no attribute name found instead of the generic error or whatever happens to be out there. So you can do it to specialize the error messages a little bit more. Helps with troubleshooting. So you can customize the exceptions that are actually thrown. And the second type for creating, or reasons why, the type of the exception is an important part of the exception data. So programmers need to do some actions exclusively to one type of an exception occurs, not the other ones. So by subclassing it, you can be more specific, and you can specialize certain types of exceptions that are thrown instead of everything all at once. So some of the exceptions that actually get thrown, you look at that and they make a lot of sense actually. And you can go online and see pages and pages and pages of exceptions built in. that are all inherited from exception. So there's the common ones are the IO, end of file, reading, no input, no file found, stuff like that. You know, common stuff people usually do a lot of stuff with. So if we throw it, we got to catch it. So here's some stuff on catching the exceptions. Checked exceptions handling is strictly enforced. So if you invoke a method that lists the checked exception in its throws clause, you have 3 choices. Choice number 1, catch the exception and handle it. Okay. Choice number 2, declare the exception in your own throws clause and let the exception pass through your method. And you may have a finally clause to clean up the first one after it passes through it, if you've inherited from exception. Or catch the exception and map it into one of your own exceptions by throwing the exception of the type declared in your own throws clause. So let's try a little example here and see how that works. Basic syntax for the try-catch block, practically identical to C++. In fact, this is where the concept has come from, actually. Try some statements. Catch this exception. If this exception occurs, do this. If that exception occurs, do that. Essentially listing out all the exceptions, and then have a catch-all at the end. If none of them occur, just say, an unknown error happened. Not quite sure what to do with it. Please contact your system administrator. You see these errors all the time, actually. They're usually coming from exception handlers. If no exception occurs during the execution of the statements in the try clause, it finishes successfully and all of the catch clauses are skipped. Catch clauses are only going to be executed when a try is performed and there is an error. Otherwise, the catches are ignored. And if any of the code inside of the try block throws an exception, either directly via the throw or indirectly by the method invoked inside of it, the program skips the remainder of the code in the try block. So it leaves where it found the error, and that automatically goes to the catch blocks that are associated with it. It's kind of like a case switch, actually, in C++. Or C, or Java. So the catch clauses that are examined one by one to see if one of them matches the same type of the catch. If the appropriate catch is found, then the code gets executed, and then the execution, everything else is skipped, essentially, until you get to the end of the construct. If no catch clause is found, then the exception is thrown into an outer try, and might have a catch clause that's made of that. If not, nothing is caught. So if it goes through everything, all the catches, and none of the cases actually match, then it goes uncaught. So catch clause with a superclass exception type cannot precede a catch clause with a subclass exception type. So we have the nesting to consider. Here's an example where we have a try, classic example of reading a file and putting it into a file stream, input stream. We do all this stuff that's going to cause the exception, put it in here. And then we have the read. This is the method below in which will throw an IO exception. The read will. If it's thrown, then we catch the IO exception. And then normally there's like a print or something. Yeah, print something to the screen, system out, something about the exception. Another choice of the situation would be to do nothing but simply pass the exception onto the called method. Where if we don't put the try and the catch, the method is actually picking it up. So the method is going to throw an IO exception and do it from the method level instead of the source code level. Most people would do this, actually. This is C++-ish. This is Java-ish. So another choice for the situation is doing nothing but to put it here. Throws IO exception. If you call a method and throws a checked exception, you must either handle it or pass it through, check the documentation to see what exceptions will be thrown. These change depending upon your Java version. Older Java versions didn't have too many. Now there's a ton of different options that you might be able to pick depending upon what you're using this for or what you're programming. So you can throw an exception in a catch clause as well. Typically do this because you want to change the exception type to indicate a failure of your subsystem, because this is going to return back to the class that called it. It's going to return back, it's going to return back. So if you want to share information among different objects and actually return better information. You could throw an exception inside of an exception to tell another object that, you know, eventually maybe the program should be shut down, or maybe the database connection is the issue or something, and maybe they need to go back up a couple layers in the hierarchy and fix the connection or something, or I don't know, you know, try to resolve the issue somehow. It's a more intelligent way of kind of dealing with the problem solving. Here inside of the SQL exception, it's kind of interesting. You're going to see this inside of, like, let's say database stuff. If you're trying to run a query and the query keeps failing and keeps throwing an exception, is it really the query's fault? Not really. It's probably the connection object that's at fault, maybe because you've lost the connection. So in this particular case, we're throwing a new servlet exception. There's a database error because the SQL exception was thrown, saying that we couldn't run the query. Instead, we have a database error. So, and then we're going to throw a set clause on the database error. So when the exception is caught, the original exception can be retrieved. This chaining technique allows you to throw high-level exceptions in subsystems without losing detail of the original failure. So you still have the original failure that is caught and tried, but you're able to throw an exception inside of it. So finally, we have the finally clause. So finally, you want to do some actions whether or not an exception is thrown. Finally clause does this for you. It's actually kind of just a ignore it. Whether the exception is thrown or not, this clause will actually be in effect. So we have a graphics G image get graphics. Try this. If not, try that. Otherwise, catch this. If not, finally at the end, when we're all done with this thing, it's not a default because it's always going to work. It's always going to run. You know, close it or dispose it, clear it, do something. So some code which will not throw exceptions to occur, and some code that may throw exceptions in between. No exception is thrown. We get 1, 2, 5, 6. 1, 2. What is this doing here? Show dialog, air dialog. Okay, whatever. Those are the steps. 1, 2, 5, 6. Anyway, an exception is thrown. The catch clause, one of the catch clauses is going to be executed, and then we're going to get the last one. So an exception is thrown but not caught by the catch clause 1 and 5, and the exception is thrown back to the caller of the method. You can use finally clause without a catch clause as well. Sometimes finally clauses can also throw an exception depending upon what code is actually happening in the finally. Sometimes you see it like this, where you see search for something, throws a stream exception. This is all part of the method body, method header, excuse me. Open up a new file stream for the input, put some code in here to do the input into the stream. Finally, input.close. This may throw an IO exception, especially if it's not open. So the close, or it's already closed, it might actually throw an exception. So if you try to throw an IO stream exception in the finally clause, throws an IO exception, the original exception is lost, and the IO exception is thrown out instead. A situation you'd better avoid, because what ends up happening if the finally clause throws an extension, it replaces whatever exception. It replaces whatever queued up exception was already available. So if you've ever seen a situation in which IO exceptions just keep getting thrown one after the other, and you really only see the last one. Because they're all hidden in there, but it's the last one that you end up actually seeing on the screen, which is essentially what's going on here. You might miss some important details of your troubleshooting or of your error handling. You might not actually catch it if your finally is actually going to be throwing something. So you don't want to throw it. You don't want to have to finally throw anything. I/O packages. So just as we saw in the last lecture for collections, we had java.util. Now we have java.io. Defines the I/O in terms of the streams, ordered sequences of data, and have a source of input stream or destination output stream. Essentially dealing with opening and closing files and using them inside of Java programs. And in fact, the I/O library has limitations for applets, actually, which is one of the interesting things. You can use a little side note about Java, actually. What we've been doing in this class so far, I've been creating applications. To create an applet, instead of extending from object, in terms of our inheritance, we extend from applet. And when we extend from applet, it's a specialized object that performs its I/O, performs its utilities. Everything is done from an applet instead of an application environment, which I'm sure most of you have seen already when you go to websites from an internet perspective. Actually download the .class file. The .class file sits in the cache directory of your web browser, and you're running the applet program, the Java program, from a JVM from your web browser instead of your computer. Well, the I/O package knows which object is from applet and which object is from application. Application is the default mode, so you never even see that really. You just see applet in there. And it restricts certain activities. As an example, applets can't open and close files. They can't read and write. Could you imagine what would happen? You can write a bunch of viruses that way. So part of the Java security, part of the protection system that's put in is restricts the I/O. So this package is actually kind of interesting. If you don't work with applets, and most of you probably won't because applets are sort of a thing of the past, still being used, but not so popular these days. And they're slow. The entire program bytecode has to be downloaded before it can be run. And you've got the advantage of being able to write in Java, but the disadvantage of the fact that you're giving your code away because you're getting the .class file on every computer out there. So there's kind of a waste of data exchange, a waste of data file download, unsecure, and we're going to take that .class file, decompile it back into Java bytecode, and steal your source code. So now, instead of applets, we have JSP, and we have Java beans, we have servlets. We have all sorts of stuff. Instead of putting it on the client end, let's put it on the server end. So you log into an application, and it's invoking the object on the server, and it's running it on the server instead of downloading it to the client, and instead of giving it away, essentially. You're keeping it protective on the servlet level. And the servlet level does everything an application level does, because it's running on your computer. It's not running on the client's computer. So you got more options, and you can use the same I/O. And the interesting and the good thing about Java, just to extend this sales pitch a little bit further, you learn the language once, and then you can write Java beans and servlets and applets and applications, and it's all the same language, different tools. So after this class, maybe you can experiment with the Enterprise Edition, RMI, some of the client-server computing models and stuff. All the same Java code. You just get familiar with the Apache server, know how to load up a servlet, know how to put a servlet, which is nothing more than a small program. A Java bean is a small program, that's working with a servlet sometimes. But in long story short, it's all the same programming language. It's just how the environment is just basically changed. So going back to the I/O package, just like the util package, going back to that concept, we have built-in functionality. Two parts. We have the byte streams and the character streams. So it's dealing with reading stuff in and sending stuff out. So look at the Java API, actually, for information about what's included in the I/O package. But some information on the concept of byte streams. Two parent classes, and some of the stuff, it helps to sort of know the hierarchy, which is what this is doing for you. You don't really have to, as long as you know what methods, what objects to create and what methods to call on those objects, and you end up using the same ones over and over again. But if you're curious in knowing, there's two parent classes for byte streams, because what we're looking at is byte streams and character streams, which is the only thing we can really do with I/O. In terms of the byte stream, our abstract classes are input stream and output stream. So we can extend those classes to create, specialized ways of reading and writing byte streams of information. Input stream class has abstract methods, read, write, open, close. Throws I/O exceptions, obviously. The designer of the concrete input stream class overrides these methods to provide useful functionality. So you can override them and create my new I/O stream, my new output stream, input stream, output stream. Example, input file stream class. The method reads 1 byte from a file at a time. So in C or C++, we've got some classes that are done read a line by time, read a comma delimited, space delimited, read it in different file modes, read, write, execute, all the different stuff. It's just very similar, but yeah, you can definitely customize the stuff or use the implemented classes already. Input stream class also contains a non-abstract method to read an array of bytes or skip a number of bytes. So you can get rid of, let's say, for example, only read 80 lines per line, or leave off line return characters or special characters or something. In terms of writing the bytes, output stream is used for that, as you might imagine. It defines an abstract method to write, so we read and rewrite. Output stream class also contains non-abstract methods to write out the bytes that specifies byte array that it read in. So if you didn't want to, we have non-abstract and we have abstract. So we can implement it to specialize it, or just do a generic read or generic write on the particular data. Close the stream after reading and writing to free up the limited operating system resources using a close, essentially. Imagine. Here's some example code, actually. I've actually put some, I know there's an IO stream example out on the website as well. Java IO, just like Java util. But now we're going to make a class called countBytes, and we're going to read it in byte by byte, and we're making file stream, because we have got IO in here. New file stream, argument 0. So we can send it the name of a file, essentially. And take this here, this string arguments from the file. So when we ran this class, we can say count bytes space the name of the file, or the name of the IO indirection. Maybe it's coming from the keyboard, or maybe it's coming from a file. Throw an IO exception, as we've seen. So integer total is equal to 0. In, which is our file input stream object, dot read. And actually, when you look at a lot of the source code, you'll see in, out, close, open, my new file stream. People just use the same names over and over again. It just makes it easier to read somebody else's code. Total plus plus increment it in dot close, and then print it out total bytes along with bytes. Here's another example that translate the bytes, doing essentially taking in an array character by character and manipulating it. So to run this, we type in Java translate BB, enter big boy, type in the keyboard, output will be big boy. So it will look at the position. This particular example is basically capitalizing the first character of the new words, essentially, by just doing a translation. So don't worry about the source code. What you're looking at is the concept of here creating a system, a file input stream object called IN, and then looking at in terms of here taking what is this, throwing IO exception, byte from this particular array and leaving out the object actually and writing it out, doing a system out. System in read, system out write. So actually the system out print line you guys have been doing already if you've been sending stuff to the screen. So it's all part of the IO libraries actually. And by default you actually don't have to do this in Eclipse. You're already using system out without it. So by default that library is already in there. Character streams, if we're not reading in bytes, we're reading in characters. That's the only other object we have. So we have two parent abstract classes for that, a reader and a writer. And each supports similar methods to those in the byte stream counterparts. Kind of the same instead of reading it. Input stream, output stream, we have a reader and writer. The standard stream, standard in, system.out, system.in, and system error existed before the invention of the character streams. So they are byte streams, although logically they should be character streams. Doesn't really matter because they both work the same way. In terms of if you're sending character data in a byte stream, it's going to be treated like a character because it's being treated as an object actually coming in. And so you do something on the object. If the object is a string type, it's going to be read like a string, which is going to be a character versus a byte. Conversion between byte and character streams also possible. Conversion is an input stream reader, and output stream reader translates Unicode and byte streams. Never, ever, ever going to have a problem. You're never, ever, ever going to use this until you have an application that reads and writes files and deals with different file types, byte streams and character streams, and you have an error because something's not formatted correctly. Then you end up going, oh, well, we need that other one. We need the input stream reader instead of just input stream. You translate the bytes to the characters. Otherwise, system.out does it for you. System.in does it for you automatically. Read. It's going to do take the bytes from their associated input stream and convert them into characters using the appropriate encoding on that stream. Write. It's going to do the opposite. So. We see inherited classes, and this is actually kind of an interesting note to make at this point. For regular old input-output for your DOS console applications, your Unix applications, you're just using the standard I/O libraries. What ends up happening is we get wrappers on the libraries or subclasses for Android development, for mobile devices, now on standard PC platform. We're just basically redirecting. It's not really even a redirecting. It's reformatting and using objects to send it to input-output in error, which works with essential, going back to the old Unix concept, standard input, standard output, standard error. We basically have specialized classes that work with Android. And voila, we write a Java program, looks like any other Java program. We use specialized subclasses that create the right location to put the output to and take the input from. And it's all done for us, which is a lot of what the APIs are providing. And then the APIs are also providing the higher level classes, the packages that deal with the features of the phones and the features of the text messaging and the web browser and all of the internet related activities and messages and warnings and alerts and all that other stuff that might be something that you will never normally find in the standard Java packages. But the programming is the same. Although Android development uses an XML interface for the screen mockup, which again is kind of interesting. It's really easy. XML is easy compared to like using an MFC library for a Windows platform. XML interface is actually kind of simple. And you're creating objects in the interface. Give me a new input box. In the input box, read the stream of characters that come through it and translate to this. So once you learn Java, then you can do Android development quite easily. Actually, it's not too hard. I'm hoping in next term I'm going to be able to teach the Android class again. That one I taught a couple years ago. It was fun, but unfortunately we didn't have offered Java before that. So half the students when they're struggling learning how to learn Java, I'm like, it's much better to take this class first and then take the Android class. And then you can, we were actually doing a lot of stuff. We wrote text messaging programs and a little map program. You can show your house and stuff on a map using the map services and SMS services and stuff, which is just creating objects, reading and writing the SMS services. So not too hard. Actually, a lot easier than iPhone development, by the way. Android development is so much easier. You don't have to learn Object-C. You don't have to learn. You don't have to do any of that stuff. The Apple tools. It can be done on a PC. You don't have to worry about owning a Mac either. So you can use Eclipse for it as well. It's not bad. Working with files. Just finish this up. Sequential access, random access. It's a lot of the same things you'd think in other programming languages is also supported. The file stream, the file input stream, file output stream, file reader, file writer. Allows you to treat it just like a stream. In fact, it's all the same in terms of the abstraction. And each file system type has 3 different types of constructors associated with it. The constructor takes a string, takes a file, or takes a file descriptor. File descriptors are normally pointers to files. If you remember from the C, C++, if you've got that, we did a file open and we sent it to a pointer, and the pointer was a descriptor, and the descriptor pointed to the file. So we can essentially work through the pointer and not to the actual reading and writing to the file, which is, a little bit more time consuming. And then if you're a C programmer, you learned about buffered I/O after that, and how to do the file. The 2 multiple libraries there are for buffered versus non-buffered I/O. reading and writing in terms of system call level or API level. None of that in Java. It's all the same. So, in fact, it's the same packages, same objects. You can just go back and do it at a low level if you want, or you can take it up and use higher level streaming if you want. Random access allows you to read write from the data from the beginning at any specified location, not from the start of the file to the end of the file. You can just randomly go to any part and read half the file. File pointer is used to guide the starting position. In fact, that's what the file descriptor is. It's a file pointer. And no, we don't have pointers in Java. We don't have dynamic memory allocation in Java either, but we have it. It's just that we don't have to do it. The packages do it for us. So. It's not a subclass of IO stream, input stream, or writer because it supports both input and output on both the bytes and the characters themselves. Here's an example in random access file. I believe you can cut and paste this and throw it into an Eclipse file. You see we've got file 1 and file 2. They're going to be open up in the R, the read and the read writes modes, the different modes you can possibly open something in. Same concept as in other programming languages, but they're method calls instead of function calls. Objects that you're creating instead of file descriptors with pointers. When you create the object, it automatically turns into a file descriptor for you. So it's built in terms of the functionality. The file class. So the file class is particularly useful for retrieving information about a file, a directory of files, anything from the disk. So a file object actually represents a path, not necessarily an underlying file. And a file object doesn't open up anything or provide any file access capabilities. It just gives us the information. So, 3 constructors take on the file name, the path and the name of the directory, the name. Methods can read, exist, is it read write, read only, get the parent, get the length. Think of them more along the lines of directory information methods, essentially. And this actually goes back to the concept of creating a, I wouldn't say symbolic link, but a symbolic, let's not use the word symbolic, an abstract of the file system. So you can use the file as this is the directory, and go through it, because it helps when looking for information for files to open, searching for content, wondering if something is there, in terms of some troubleshooting, looking for a class file, it's not there, check this other directory, check that other directory. You can use a file object to manipulate that. And you can also add more efficiency. So you can have a buffer reader, as I mentioned before. We can do low-level I/O, buffered I/O in C, C++. We have that capability in Java as well. The buffered I/O is from the buffered reader. Separate object adds buffering. Reads text and characters from the input stream, buffers them in some temporary memory that provides efficiency. Because we all know reading and writing from I/O, from hardware, from a disk, from a USB drive or something, is not too fast. It's actually kind of slow. So we can read the whole file and put it in a buffer. Go back to it eventually and look at it again if we wanted to. For example, write the input stream reader inside of a buffer reader. So we can do a buffer reader in is equal to new buffer reader, new input stream. So to wrap it. So, one of my downloaded examples from, I want to say lecture 2, one of the earlier ones, it may even be lecture 1 or 2, has examples of the buffered reader stream and the I/O streams. I didn't have enough to put it in, the examples to put it in like a full one for this one. It was only 1 or 2 files. And most of them are repeated in this lecture. But you might find some of this stuff actually in one of the other downloaded files. Here's another example of an efficient reader. It's just going to make instances of the object of the buffered reader object and use that inside of a file reader. So if you want any more information on error handling, exceptions, reading and writing to files, and accessing files and permissions, here's some good links. And I believe the links still work. Actually, the sun should automatically go to Oracle these days. Yep, it does. So everything that says sun, although it does look outdated, it's still relevant. It still works. Just goes to Oracle. That was kind of a quick way of going through everything you ever wanted to know about file I/O. Which brings us to our next assignment. Swing! Let me show you the assignment first. And then you'll kind of see, and then we'll go and we'll look at the swing and you'll go, oh, this is really easy. I think. Let's see. I'm sorry? It's built in already. It's one of the standard packages. You can use AWT or swing, actually. Oh, it is for GUI. Yes, front end. Front end GUI interface. Assignment number 4. Your last assignment. Is this your last assignment? Your last assignment. We have choices. I could go through this today or I could skip it tomorrow. Let's talk about swing then, and I'll go through this. Because if I start this, this is long. You're right. If you wanted to create a DOS console or Windows application, if you want to create a Windows application, Eclipse, this is actually written in Swing. This has got Swing components in it. Gives you the, well, let me just look, you'll look at the pictures here. I'll go back to this assignment for a second. It gives you this windowing. It gives you the menu system, the windows, the components that are on the screen. You can create JMenus, file I/O automatically for you. It's kind of like doing the MFC Microsoft Foundation class development, or creating RCs and old C programs. Visual Studio had an RC component to it where you could create windows and interfaces. Visual Basics got it built in automatically. You drag and drop on a canvas and you add items to the canvas. It's GUI based. There are some GUI based tools for the swing. However, in fact, I think NetBeans actually includes something that does GUI development for you, kind of like Visual Basic, where you add and drop items on the canvas, and you have property boxes you can bring up and set the title of the menu and so all this other stuff. It's a higher level programming language abstraction. However, the swing components themselves are pretty easy. In fact, I'll just preview it here for you for a second. Yeah, you're not going to use Swing with that. If you're doing JSP, you're working with HTML as your markup language. Yeah, you're not going to be working with Swing. And you have made actually a good point. The Swing components and even an AWT Abstract Window Toolkit package has limited use these days with the internet. You don't use it with the internet. I mean, you could put it in an applet if you wanted to, but it doesn't really have very much of a home outside of that. Well, let's just open this project real quick and we'll see what we're going to look at tomorrow. Hopefully I'll get some of you guys to come back then tomorrow. This is your bribery here. Let's see. I don't have to bribe you, it'll show up anyway. Java pad. This is what we're building, actually. I'm going to run it as an application. This is not an applet, by the way. It's an application. And it should open up a window any minute now. Yeah, let me just close this up so you can see. Here's my window. It's a text editor, actually. And the text editor has got a menu on here, file, save, but it doesn't have any of the other menus requested. So this is a test. So you can like write your own notepad version. The file, save. All this stuff is a couple of objects. So yeah, save test. Maybe this will put it on the desktop. Here's my desktop right here. Right here, test. Call it by txt. Oh, here's that file. Here's that file. This is not gonna. It's gonna open it up in text edit. But essentially, what I've done is created my own notepad, and what I'm gonna go through tomorrow in a lot more detail. I'll just show it to you right now. Actually, the source code for it. It's amazingly easy compared to what that functionality just looked like. So this is actually extending Swing Java I/O. So this assignment, the purpose of it is to look at exception handling, which we just covered, look at the I/O, opening, closing, saving files of byte stream and character streams, essentially. Experiment a little bit with Swing and experiment with a little bit of the Abstract Window Toolkit, AWT. And what it's doing is extending JFrame, which is part of Swing. So, I'm sorry? Oh yes, I'm sorry. I keep thinking you guys can see this from where you're sitting. Thank you. So here are the packages that I just showed you a few minutes ago that you couldn't see. And we're extending, I'm creating this class JavaPad that extends JFrame instead of, I could extend applet if I wanted to create an applet from this. And if you're doing that last assignment, you'll kind of see how that the code is actually an applet. And you're taking the applet and you're turning it into an application. And if you missed the morning session, you should know that assignment number 5 is optional. You don't have, this is the last one of the assignments. You don't have to do assignment number 5. But we're extending, it's extra credit actually, 5 points extra credit if you want to do it. But we're extending JFrame, and we have these components that we're using. We've got a JText area, JFile chooser. This JFile chooser, that was opening up that dialog box. I made a new instance of this object that gave me a way of opening and closing files, all automated. Same thing you get in like Visual C++ actually. You can get, I think they call it file chooser or something like that as well. There's something similar. And then we create actions for the menu items, open action, save action, exit, and these are for menu items that we're creating. Here's my main program, here's my main driver program. It creates a new JavaPad. This is more typical of what you see applications doing. Main opens up and creates a new instance. That's it, of whatever object this thing is working with. And the object that's working with, here we can create a scrollable text area that we've got inside of. And what I'm going to do, actually, I might actually wait and do this, maybe wait and do this tomorrow, because this is kind of a weird spot to get halfway in the middle of. I'll see what the next lecture is all about, and we'll maybe skip this for a second and visit it tomorrow from its entirety. But what we're doing is essentially nesting components inside of components. We make a JFrame, and we put a container in there, and we put stuff in the container, and it's all layered in a hierarchy. And just like Java is sort of hierarchical in fashion to begin with. Inside the text area, we can set the border, we can set the font of the text area. We can have a panel that has the content, we can set the layout to certain styles. Is it going to be left justified, right, centered, stuff like that. We can create a menu bar. That menu bar that said file on it is right here. This is 2 lines of code actually. The menu bar adding file is an option, and then we have file, we have added open action, save action, a little separator, a little line down the center, exit. We can set the window content and the menu. We can set other window characteristics if we want, the close operation, stuff like that. And then we have basic functionality that we're performing for the open, for the close, and for the exit. And what we're doing there, in fact, here's for, like, say, the open action as an example. Open calls back to super from abstract action that we are extending. So we're inheriting. This is using inheritance because the open action is extending from abstract action, which is part of the I/O that's going to say, pick a file and open it. And this is just nothing more than making the O hotkey, like you press alternate O on your keyboard, and it will select a menu item for you. And then you have, not only do you have the action of the representation of the open menu item, then you have the action that's performed on the event. So we have action events, which kind of gives us our event-driven behavior. Because we move around the mouse, we click on something, it's selected, we press close, and the activity of the actions and the clicks and the things are the interesting part. And then we have the file reader here, new reader that's going to open up, and that we just looked at a few minutes ago. So we're building in the file concept of being able to open and close files. So this particular assignment sort of deals with a lot of subjects that we've already sort of covered already. And then obviously you're going to want to put in some exception handling, I believe, as well. And for that assignment, I've got a text editor example. that I have out here, actually. I should have out here. Let's see. Refresh my memory, actually, real quick here. Because I'll be going through, hopefully, if it's there. I'm pretty sure I updated it. Oh, there's a how-to video that goes through the example, and then the example oh, another one I left out, I think. I will, between tonight and tomorrow, put the example up there. The example is going to bring up a small little text editor, which is going to have different requirements than your program. Your program is actually creating the JPad, the text editor, the JPad one. However, the menu is incomplete. The menu only has the file menu. So I don't believe I gave you the code. The last time I taught this course, I didn't put it up here because I didn't want to sort of give it away like that. Because you could essentially just take the code and add the menu and you'd be done with it. So I'm going to find another example that I've been using that doesn't exactly do the assignment for you in its entirety. So makes it a little bit more challenging for you. But I will be going over that tomorrow. So that one is lecture 8. Let's see. Still got a little bit of time left. Let's see. Do we want network programming? Actually, I'll put it in your hands. We got topics left. We got network programming, which I have optionally not covered in some courses. So I'll leave it to you. Think about that topic for a second. This one I always cover. Documentation, garbage collection, nested classes, and interfaces. The other one that I always cover, I believe, is this one, which is sort of the capstone on object orientation, which is our menu items for tomorrow. I could start this one, actually, today. Or I could let you out early. Well, I was thinking about going, if I were to continue till about 3:30. But it's already 2:15. The problem is we're in an awkward state of the lecturing. I got to start with a brand new topic because I can't finish the swing stuff today if I were to start it. So, how many? Raise a hands. We'll have you vote. I know everyone's going to put their hand up. How many people would like to be done with it for today and just go out? Yeah, no, not this. Not do anything. Leave. How many people would like to go home? Only one person? 2 people. Okay. Let me rephrase that. How many people want to stay longer? Really? You want to stay till 3? All right, let's do it. Everybody else is going, man, I should have just raised my hand. Well, actually, we're actually in pretty good shape, actually. We could go, actually. Well, it means that normally on a Sunday, the second, I don't normally take it past the lunch hour, but we'll stay a little bit longer past the lunch hour, maybe. Yeah. You want to stay today?
Why would you?
No. We're actually on. I'm actually ahead of schedule. I'm good. You can still leave early tomorrow too. Oh, let's just call it quits. All right, we're done for today. Just a FYI, just because I do have a few minutes here. We have some interesting things coming up for this course. As you know, this is the second class meeting of our 3 series. So we have September 17th, 18th, October 1st, 2nd, 29th, 30th. This is the last weekend of October, which is when we're supposed to have our final exam, which is like about a month away. So I will be having I'm supposed to have final exams that weekend. So you'll come and you'll take the final exam that weekend. If you don't want to take the final exam that weekend, you can take it with the other section of this course, which is going to be taking it, don't have the exact dates yet, but it will be sometime towards the end of November, another month down the road. So you have a choice. You could get it over with now, at the end of October, or you can get it over with at the end of November. So I'll put that in your hands, just like, because some people are wondering, what about next time? Well, the last session was only 2 weeks ago, but the next time is going to be like a month from now. So just in case I don't see you tomorrow, because I see some people on Saturday and I don't see them on Sunday. Your attendance is mandatory for the 29th or the 30th.
So finals on 29th?
Correct. I'm going to switch you. You know what I will do is because we don't actually have that many in this class, I will have it open. You can come on the 29th or you can come on the 30th, but you don't have to come both days. So when you book your flight, do it for one or the other. The times of the exam will be from 10 o'clock in the morning till, 3 o'clock, 3 or 4 o'clock in the afternoon. So that's the window that you're looking at. So you can kind of plan ahead. Some people might have another course running the same weekend, and if you're coming down for that, you can do both courses this time instead of having to juggle between the two. And then plan on, and in fact, I will have an easier exam for the people who want to take it on the 29th and the 30th. It will be an easier exam than the one that will be offered at the end of November. And it will not require any programming. This one will not require any programming. Although you'll have multiple choice questions, I know I have hands up already, you'll have multiple choice questions and you'll have fill in the blank questions and short answer questions, but no actual code writing. The exam in November will have code writing. And I know your question in the back is, can we take this one in November? No. Is that your question? No. Okay, what was the questions back there? Or did I answer it? Huh? It's a choice? Yeah, it is a choice. Well, if you prefer to take the easier version of it and show up and take it when you're supposed to take it in a month from now, then you get an easier exam and you get it over with. If you want to wait until the end of November, you're going to get a harder exam. Yeah?
So do you get no lectures on those 2 weeks?
No, just the exam. Yeah. I have to reserve it. Huh? Oh, good question. I will post for you guys, and I'll have the TA send it out, a topic list. I haven't written the exam yet. So once I write the exam within the next couple weeks, because now I have to think, no programming, after I just said that. Actually, I was thinking about that anyway. After I write the exam, I'll come out with an exam review sheet that'll say this is for the weekend final exam for this class, and it'll be a Microsoft Word file. I might put it into a video to talk about it a little bit, so I can ad-lib it a little bit and tell you some key examples. Or I might just put the doc out there, and it'll be out here under the weekend. I'll clearly mark it up front next to the syllabuses that this is for the weekend final exam review. And I don't believe I'm going to have anyone from the weekday wanting to take it, but I guess I could open it up to them too to make it fair, I guess. It just seems kind of odd that it's so close. It's at the end of the month. This is October 1st. It's at the end of this month. But if you guys remember from last time, I said that the assignments, everything is not due till the end of the term, and it's the same assignments. And you still can skip number 5 if you turn them in November versus October. So we'll get out early today, and we'll go tomorrow. Questions? The midterm is due before everything is due before the end of the term. And the end of the term is at the end of November. Your term is supposed to end at the end of October, but give yourself another month. The LMS is where you need to upload these items, and unfortunately the LMS isn't even ready. So it doesn't have anything in there. So it's impossible. Even if you had it all done, it's impossible for you to turn it in. I hope that it's available by the end of the month, but I'm not holding my breath. I mean, it's a new system, so I don't want to rely on it 100%, so I'd rather give yourself an extra month. You don't want to wait until the end of November to upload your stuff in the LMS. Every single term, same problem happens over and over again. Every student waits, and then the last week, the LMS goes down. And then they go, oh, I can't get everything in, and the deadline passes, and then you got a hassle. It's always better to beat the rush, turn it in before. And just because it's not due until the end of November doesn't mean you shouldn't be working on it now. So the last interactive session, I went over the midterm exam, actually, and I gave you everything you needed to know for that. And I don't believe I have access right now. The internet is not responding, so I can't show it to you right now, but the midterm exam is out here. It's a take-home exam. Normally, you would be taking it in class if I were to have it this weekend, so, but it's a take-home, so you don't have to take it in class. No, I can't get to that. I've been clicking on this trying to get to it for a few minutes. It's not working. Internet's may not be working right now. Any other questions? So tomorrow we'll start at 10 in the morning, and we'll finish everything lecture-wise. We don't actually have that much left. We have swing, which is the biggest topic, and and assignment number 4 to talk about. That's the big meat, and then the object-oriented stuff is it's not that big of a deal. In fact, it's a repeat of everything I've been talking about already in terms of the object-oriented concepts. So, if there aren't any questions, we're done. Okay, very good. Thank you. Thank you all for showing. Make sure to sign the roster if you haven't done so already.